What if somebody handed me this and said, find this exactly? Anytime you see the word exactly, that means if you're using your calculator, you're doing it wrong. What if I wanted cosine of 50, cosine of 10, minus sine of 50, sine of 10? I don't know cosine of 50. That's not in my unit circle. I don't know sine of 10. I don't know any of these. But I have to look at my formula sheet and see which pattern this matches. So I look through all of these formulas and see which one this matches. Well, I've got a cosine, cosine, minus sine, sine. That matches this formula here. So that's cosine of x plus y is cos x, cos y, minus sine x, sine y. And here the role of x is being played by 50, y is 10. So now I'm going to work this formula backwards and say, oh, I'm really looking for cosine of 50 plus 10. 50 degrees plus 10 degrees. Oh, well, that's 60. I know cosine of 60. That's on my unit circle. That's a half. I'm done. Without getting my calculator out. I never touched a calculator. I worked the formula backwards until it matched something I know. If you see something like this, it's going to be a unit circle angle, and it's going to be something you know. Okay. Something else we can do. These are really interesting problems. What if I wanted cosine of theta minus pi over 2? Well, it's an angle minus an angle, so that I'm going to be using this formula. So that would be cosine of the first, cos of the second, plus, because the cosine minus formula has a plus in it, sine first, sine second. So who's playing the role of first here? X here is theta, and y is pi over 2. I've already taken that. Y is not negative pi over 2. I've already taken care of the negative by using the formula that has the negative in it. So this would be cosine of theta, cosine of pi over 2, plus sine of theta, sine of pi over 2. But wait a minute, we know unit circle. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So 0 times anything is 0. Sine times 1 is sine. We just get sine of theta. So what we've proven here is that these are in fact co-functions. Sine of one angle is the cosine of the complement of that angle. Sine of 20 is cosine of 70. That's what this says. Something else we could do with this. We've always said that the period of sine and cosine is 2 pi. I can prove that. I can prove that sine of some angle plus 2 pi is the same thing as sine of that angle. I'm literally proving that sine has a period of 2 pi here. So sine of 5 degrees is the same as sine of 365 degrees. If I add 360, I get the same answer. I'm going to use the addition formula for sine. That one is sine of x plus y. We used to have to memorize all these back in the day. You guys get a formula sheet now. Sine of x plus y is sine x cos y plus cos x sine y. So here, x is theta, y is 2 pi. So sine of theta plus 2 pi would be sine of the first, cosine of the second, plus cosine of the first, sine of the second. Cosine of 2 pi, I know that, that's 1. Sine of 2 pi, that's 0. 0 times anything is 0, that whole term disappears. Sine times 1 is just sine. And that's what we were trying to get. We're done.